Ohm's law is fundamental in HVAC systems, helping technicians understand the relationship between voltage, current, and resistance, which is important when troubleshooting an electrical circuit. Ohm's law states that the current, or I, flowing through a conductor between 2 points is directly proportional to the voltage, E, across the 2 points, and inversely proportional to the resistance, or R, of the conductor. If you have taken any kind of test recently on electrical components, or you took the NATE test recently, you probably saw this wheel that lists all the equations that can be derived from Ohm's law. In this video, we're going to use some examples to show how this works when troubleshooting an electrical circuit. As we stated previously, the symbols I, R, and E are used in Ohm's law. I is the current that is flowing through the circuit, and it is measured in amps. R is the resistance that is in the circuit, and it is measured in ohms. E is the voltage being applied to the circuit, and it is measured in voltage. These three circles show us how we can work up the equation for Ohm's law. E, as we said, equals the voltage being applied to the circuit. R equals the resistance in the circuit. And I is the amp draw of the circuit. If we want to find the voltage, or E, and we know the amp draw and the resistance of the circuit, according to the first circle, we would multiply I times R to get our voltage. If we know the voltage of the circuit and we know the amp draw of the circuit, and we want to find the resistance, or R, of the circuit, we would divide the voltage by the amp draw to get our resistance. If we know the voltage and we know the resistance in the circuit, and we want to find out what our amp draw is, we would then divide the voltage by the resistance to get our amp draw. In our first example, we want to find out how much voltage is being applied to our circuit. We know that we have a 2 amp draw on the circuit. We know that our resistance is 100 ohms in the circuit. So we want to find our voltage. To do this, we are going to multiply our 100 ohms by 2 amps, which will give us our voltage of 20 volts. So in this example, we want to find the amount of current flowing through the circuit. We want to find I, or our amp draw. We know voltage and we know resistance. Voltage is 12 volts, resistance is 10 ohms. So we divide 12 volts by 10 ohms, and it gives us an amp draw, or current flowing through the circuit, of 1.2 amps. Here we have an electric motor that runs on 240 volts and is drawing 6 amps. We want to find what the resistance of the windings of this motor are. The equation for this problem will be R, or resistance, equals the voltage divided by the amp draw. In this case, we have 240 volts divided by 6 amps, which gives us a resistance in the motor windings of 40 ohms. As you saw on a previous slide, there are many different types of formulas that can be used to work these equations. Watt's law is also a part of this, which is the electrical power, that is the rate at which electron flow does work. Electric power can be calculated by using the Watt's law formula by putting watts where the E was previously for electricity. By using the Watt's formula, we can find out how many BTUs an electric resistant heater gives off. So in this example, we have an electric resistance heater that gives us 3.42 BTUs per watt. We want to find how much heat will an electric resistance space heater give off if it draws 20 amps at 230 volts. First, we need to change the amps to watts. We do that by multiplying the amps times the volts, which gives us 4,600 watts. Then we change the watts to amps by dividing the watts by the volts, which gives us an answer of 15,732 BTUs being produced by this space heater. In this example of Watt's law, we want to know how many amps are going to be measured on a 10,000 watt heating element when 230 volts are applied. In this case, we are trying to find I, so we are taking our watts divided by our voltage, and it gives us an answer of 43.48 amps. In this example, we are trying to find out how many volts are applied to a circuit with a 8,500 watt heating element with a measured amp draw of 40.4 amps. The equation is E equals P divided by I. So 8,500 watts divided by 40.4 amps gives us an answer of 210 volts. There are many ways that Ohm's law can be used in daily troubleshooting of HVAC equipment. We have given you a few examples in this video. We would encourage you to pursue more information regarding implementing Ohm's law into your troubleshooting procedures. The internet and YouTube have many tutorials on Ohm's law and practical applications. It is up to you, the technician, to pursue continuing education to sharpen your skills in the field. If you enjoyed this video, click the like button and subscribe to this channel to make sure you don't miss new videos each week. Thank you for supporting this channel.